Hello, welcome to the FRQ of the day. So now today's May 4th, so that's Star Wars Day. May the 4th be with you. So I'm wearing my Star Wars tie. You see my Star Wars tie? So I think that's pretty cool. So anyway, so let's look at this one now. And today is the day that you should be getting an email from the College Board in regards to doing the demo of the test, so you can practice uploading answers. And that's a really important thing, that you practice uploading answers and figure out what's best for you, and make sure you're cool with that. And you have any questions about that, please contact me, because we need to get that worked out. That certainly shouldn't be any barrier at all. I think it'll be fine, but we just need to make sure and work out any glitches that we're having in your situation. We got time to do that, but make sure and practice that now and try different things and figure out what works best with you. And this is the very sort of problem that I think is going to be in the exam this year. As a matter of fact, it could be, there's going to be 2 questions on the exam of this year. And, one of the gurus said that he feels that both of them could very well be inference things, and then it's not gonna be an A and a B, it's gonna be A, B, C, and a D. There'll be, one of them is like 20 minutes long and the other one's like 15 minutes long. So anyway, so one of the 15-minute one is like gonna be like this, maybe have a part C to it, but it's gonna be like this, and in the sense that it's gonna be, interpreting how data was collected and that sort of thing. So let's make sure we can do this one. So this one says a French study was conducted in the 1990s to compare the effectiveness of using an instrument called a cardiopump with the effectiveness of using traditional cardiopulmonary resuscitation, CPR, in the saving of lives of heart attack victims. Heart attack patients in participating cities were treated with either a cardiopump or CPR, depending on whether the individual's heart attack occurred in an even-numbered or an odd-numbered day of the month. Before the start of the study, a coin was tossed to determine which treatment, a cardiopump or CPR, was given on the even-numbered day. The other treatment was given on the odd-numbered day. In total, 754 patients were treated with a cardiopump, and 37 survived at least 1 year, while 746 patients were treated with CPR, and 15 survived at least 1 year. Part A, the conditions for inference are satisfied. State the conditions and indicate how they are satisfied. And Part B, perform a statistical test to determine whether the survival rate for patients treated with a cardiopump is significantly higher than survival rate for patients treated with CPR. So if you wanted to pause the video here and give this a shot, that would be great. Okay, so it asks us to check the conditions, and you notice we've got proportions here. We have the proportion that survived with the cardiopump and the proportion that survived with the CPR. And there's 2 proportions. And so this is a 2-proportion z-test is what we're checking the conditions for. And so we're thinking sin. And so this is what we would do. Now in this case, all right, so it asks us to list the conditions. Well, we must have either random selection or random assignment to treatments, one of those things. In this case, we do not have random selection, okay? But we do have, in essence, random assignment to treatments. Okay, so it says that it was randomly determined by coin flip as to whether a patient was treated by CPR or cardiopump. So therefore, that condition is met. Okay, so there you go. So basically, you had to say that they were randomly assigned to treatments, and make sure and say it in context by coin flip, and mention the context here. The other thing now. Then we have independence, which our population size has to be at least 10 times our sample size. But you don't have to check that, and you really shouldn't check it, unless there is sampling without replacement. In other words, we've randomly selected, and we didn't have that. We don't have sampling without replacement here, okay? Like it didn't say that they did an SRS or they did randomly selected. So therefore, we don't have to check that the population size is at least 10 times the sample size. So the other thing is normality. And so the normality, of course, with a proportion is n times p and n times 1 minus p are greater than or equal to 10, all right? And in Part A, it didn't for sure. It wasn't for sure asking us to do a test. But when we're doing a test, we're going to use the combined or the pooled p-hat, and that thing is right here. Now, actually, you really didn't have to do that. I don't think. I think they'd give you credit if you just did n times p and n times 1 minus p for both samples. But here, I found the pooled p-hat, and I multiplied it that's going to be n times p and n times 1 minus p for the first group. And then that's n times p and n times 1 minus p for the second group. So this is for the cardio pump group, and this is for the CPR group. And all these numbers are clearly bigger than 10, so normality is met. And so that was, so you had to clearly, in essence, show these numbers. Or like I said, if you just said, well, if you didn't use the pooled p-hat, if you just did 37 and then 754 minus 37 and 15 and 746 minus 15, all those 4 of those numbers are greater than 10, therefore normality is met. And that's what you do if it was an interval. But anyway, and then the other thing is to perform a test, and so we have to do our THAME acronym. So to do our THAME acronym, we have to say what we're doing. This is a 2 proportion z-test, or you could say a 2 sample z-test for proportions. That'd be okay. And then here's our hypotheses. Our null hypothesis is that the 2 proportions are the same, where p sub cp is, and it's important to define your variables, okay, very important, okay, and don't put p-hats on this thing. This is parameters, not statistics here. So this is the proportion of all heart attack patients like these, who survive after treatment with a cardio pump. Okay, it's important to say like these when you have an experimental situation where you don't have random selection. And then it basically said here, treated with is significantly higher. The cardio pump has a higher survival rate, and so that's telling me to go one-sided. And so therefore this is greater than. And of course here the piece of CPR is the proportion that survive that have CPR for patients like these. Okay, so there's our hypotheses. The conditions, we've already checked those. Okay, and so then we go our mechanics. And so our mechanics, so you had to show these 2 numbers. Now once again, you can do that just with your calculator. I'm not anticipating you have to find these things on the exam. They're probably going to go ahead and tell you what the test statistic and the p-value are, because they aren't, they're saying they aren't emphasizing calculations like that. But the big deal is this and the conditions. Okay, this right here are the conditions. But just, what the heck, let me just remind you how to do this with your calculator. So the way you would do this with your calculator, of course, you'd hit the stat button, which is right there, the stat button. All right, and so you will go stat and you'll go test, and this is a 2 proportion z-test, right, like that. And then you just enter in your 2 proportions, 37 out of 754, and then 15 out of 746. All right, and then we're going greater than because our alternative is greater than, and then hit calculate. And so there's my test statistic p-value. And so that's how I really got those things. Of course, there's the formula. That's unlikely to be on the exam this year, certainly. I got that off the formula sheet. And then drawing the proper conclusion with a p-value is very important. And you would say this p-value is less than 0.05, so I reject the null. There's convincing evidence that, and then you restate the alternative in context. There's convincing evidence that the proportion of heart attack patients like these who survive after treatment with a cardio pump is greater than the similar portion for survival with the CPR. And so in essence, what this is saying is we had close to 5% that survived with a cardio pump, and we had 2%, and that difference is statistically significant. It's not really plausible that that difference is due to sampling variability. And so like I said, that's a very typical thing that could happen in the exam this year. I think if they were going to add another part, a third part of Part C, they might ask you to, make a confidence interval and comment on the connection between the interval and the p-value. In this case, 0 would certainly not be in the interval, because we are rejecting the null hypothesis. We're in essence rejecting 0. So, or it could ask you to interpret the meaning of this p-value. In other words, when it says interpret the p-value, it means describe it as a probability. That's what the p stands for. And it is the probability that, assuming the null is true, we would get sample values this unusual, this different. All right. And so what you would say here is, well, assuming the null is true, in other words, assuming that the proportion with a cardio pump is the same as the proportion with CPR as far as survival rates, the probability we would get sample values that this one would be this much bigger than this one, since the alternative is greater than, is 0.001, about 1/10 of 1%. In other words, it's very unlikely. And that's it. That's your FRQ for the day. And once again, I hope you have a great Star Wars day. And also, I'd like to show you this. So this is one of my shirts that I got a few years ago. And Stat Wars, that's sort of what we're in, taking the AP Stats exam. And of course, every test is graded on a every question is graded from 0 to 4. So the 4s awaken means like you hope you make 4s on the actual question, so you can make a 5 in the exam. So anyway, that's it. So hope you all have a great day. Please send me any questions, and we'll see y'all tomorrow. Which, guess what? It's Cinco de Mayo tomorrow. That's right.